So that means this regression analysis, the interpretation of beta is applicable. So what I will say that the interpretation of beta or beta hat you can say is applicable only for an average individual. Okay. So, please keep in mind this is very important. I am saying the interpretation of beta hat is applicable only for an average individual in the sample. And who is that average individual? The average individual is one for an average individual who has income equals to sample average. So that means my entire interpretation of the regression coefficient is valid only for the representative individual or average individual, not for each and every individual, because the regression line itself is an average line. You look at the line, this is an average line, this is expectation of yi given xi. So that means I am predicting the income using that average line. Okay, when income changes from 60 to 70, what is the change? And how you are measuring the change? Change with reference to this line, which is basically an average line. So that means that average line itself indicates the features of an average individual who is completely different from actual individual. That is why you see from the diagram, when my income is 60, my model says the consumption should be 47.5, and that consumption is for that average individual. But if you look at in this group, when the income level is 60, not all the people are having consumption level 47.5, rather there are consumption level with 40, 45, 50, 55. That means we are committing some kind of mistakes in predicting somebody's consumption with the help of the income. Similarly, when income changes from 60 to 80, the model says the predicted consumption should be 67.5, but actual consumption is 60, 65, 70, 75. When it goes to 80 to 100, then it becomes 87.5, but actual consumption in this group is 80, 85, 90, 95. So that means we are committing mistakes in predicting individuals' consumption at each and every level of income, and that is the reason those deviations, that means actual from the predicted, actual consumption is yi and predicted is yi hat, and that basically indicates your ui hat. Okay, that is basically your predicted error term. We are committing mistakes, right? We are committing mistakes. So the interpretation of beta hat, whenever we do interpretation of beta hat, we have to say that for a unit change in income, consumption changes by beta amount or beta hat amount rather on an average. That on an average component you should not miss, because that is valid only for the average individual. Okay, that is valid only for the average individual. This is the meaning of regression analysis. Now the next question is, we said that why we are doing the regression? Because our entire objective is entire objective of this regression analysis is drawing inference about the true population parameter with the help of the sample counterpart. So, this is the true population parameter, this is the sample counterpart or sample statistic. Sample statistics, alpha hat and beta hat. Now, population parameter, the true population parameter is always unknown. Is always unknown. Then the question is, when the true population parameter alpha beta is always unknown, why we are spending so much of time in estimating alpha hat and beta hat? And even after estimation also, how do you know that we are actually predicting the true population parameter? Because they are always unknown. Now, I would like to introduce a simple analogy here. True population parameter is like our God. So, all of us, we believe that there is a God, we assume there is a God, but none of us have ever seen God. That is why God is unknown. We do not know how does he or she look like, but we believe there is a God and we make certain assumption, and those assumptions actually generated different religion, Hindu, Muslim, Christian, so on and so forth. In every religion there is a set of assumption about the God, and they say that if you behave religiously, that means what are those assumptions? Those assumptions are basically how you should lead your life so that you can reach to God at the end. Similarly, econometrician also they say that there is a God which is population parameter which is always unknown. We can always estimate alpha hat and beta hat, like each and every religion there is a shape of God. Hindu they have a shape of God, Muslims they have a different shape, Christian they have a different shape. So, these God are actually what we see is the estimate or estimator of the true population parameter alpha and beta. And each religion says that if you perform religiously, if you behave religiously throughout your life, then at the end you will reach God. Similarly, econometrician they say that if you follow certain assumptions while estimating your alpha hat and beta hat, then the statistical procedure will ensure that your alpha hat and beta hat would be as close as possible towards your true population parameter alpha and beta. Okay, alpha and beta. So, that means the line what we have estimated, this regression line what we are going to estimate, we need to make certain assumptions before we estimate this line. Then only we can say that this line is actually reliable. This line is based on alpha hat and beta hat. If we follow those assumptions, then our alpha hat and beta hat they are reliable and they would be as close as possible to the unknown true population parameter, and then only the alpha hat and beta hat would be useful for any inference making or policy making, so on and so forth. Okay. So, this line is estimated based on certain assumptions. That means we need to know what are those assumptions. So, that means when we estimate this classical linear regression model, this classical regression model is based on certain assumptions, and if we maintain those assumptions, then only our alpha hat and beta hat will exhibit the desirable properties of unbiasedness, efficiency and consistency what we have discussed yesterday. Okay. So, those assumptions are actually an idealistic situation. Like in reality, every religion says that you should be honest, you should have tolerance, you should do this, you should do that. So, those things are like assumptions. Those things describe an idealistic situation that will lead you to the God. Similarly, these assumptions of classical regression, linear regression model where we estimate alpha hat and beta hat will lead to alpha and beta as close as possible, and then only we say that alpha hat and beta hat are reliable, exhibiting the three desirable properties of unbiasedness, efficiency and consistency. So, now then it becomes important to know what are those assumptions. Okay? What are those assumptions while we estimate alpha hat and beta hat, right? So, these are called assumptions of CLRM. Okay? The model says, the first assumption it says, the regression model is linear. So, that means I am writing this type of model y equals to alpha plus beta xi plus ui. The question is then, what does linearity mean? What does linearity mean? When I am saying the model is linear, basically I am saying the model is linear in parameters. So, here I have two parameters alpha and beta, and I am saying the model is linear in parameters, and I am not saying about the linearity of the variables. That means, it may or may not be linear in variables. We can still estimate the model using the procedure of classical linear regression model even if the variable is non-linear in nature. For example, we can deal this issue alpha plus beta xi square plus ui. This model is non-linear in variable, but still we can estimate the model using the procedure suggested by CLRM, which we will discuss later, because this model can always be linearized by proper transformation. So, linearity is not required for the variables, but linearity is required for the parameters. So, this we can handle because we can take proper transformation. Okay? We can linearize, for example, if you take log of both sides, then log of yi would become 2 beta ln xi. So, if you take log, so this would become log of yi equals to log of alpha plus 2 into beta log of xi plus log of ui. You can always linearize this when the model is non-linear in variable. But if the model is like this, yi equals to alpha plus beta square xi plus ui, then this model is called non-linear in parameter. And this type of model we cannot estimate using the technique what we will learn in CLRM, that requires a specific technique called non-linear estimation method, right. So, that means whenever we are thinking about classical linear regression model, the name itself it says the linear model, classical linear regression model, which takes the form yi equals to alpha plus beta xi plus ui or yi equals to alpha plus beta xi square plus ui, something like this. because linearity, non-linearity in variable is not a matter of concern, because we can always linearize that model using a proper transformation, but it requires model to be linear in parameters yi equals to alpha plus beta square xi plus ui. That is the first assumption. Okay? That is the first assumption that we must make. Then the second assumption, it says there should be enough variation in xi to be qualified as dependent variable. Sorry, qualified as explanatory variable. For example, when we are talking about, take this sample. See here, look at the income level of several group of families. It is 60, 80, 100 and 120. Now, instead of that, if the income level for all the group is 60, 60, 60 and 60, then the observed difference in their consumption cannot be explained by income. That is very simple. If all the people are having same level of income, how can you claim their difference in their consumption is due to income? Because everybody is having same level of income. So, or let us say if it is not 80, let us say 60, 61, 62, 61.5, that difference is also not significant. That is why it says there should be enough variation in your xi to be qualified as an explanatory variable and to be included in the model. So, when you specify your model, you must ensure that all your explanatory variables, they have enough variation in them. Without having enough variation, I cannot include a variable in my model as explanatory variable. Same is true for y. If everybody is having same level of consumption, the necessity of regression itself does not arise. Why should I bother about regression analysis when everybody is same in terms of their consumption? The question itself does not arise in our mind, right? So, that is why I have not mentioned that. I assume that there is enough variation in people's consumption level, and that is why it gives some kind of motivation to us to think and understand why different people, their consumption pattern is so different, and that we are trying to understand with their level of income, and there should be enough variation in their level of income. Without a variation in level of income, we cannot include that variable as explanatory variable to be included in my model. So, this is assumption number 2. This is assumption number 2. Then assumption number 3, it says the error term, the mean value of error term of the stochastic error term, which actually captures the influence of omitted variables in the model. The mean value of the stochastic error term is 0, and it follows a normal distribution. So, that means what we know about the error term, expectation of ui given xi equals to 0 and ui follows a normal distribution with let us say 0 mean and sigma square variance. This is what we know about the error term. Now, we have to keep in mind, again I am making a very important point. There are two assumptions what we are making about the error term. This is let us say 1 and this is 2. Now, assumption number 1 is required for estimation. That means, without making this assumption, we cannot even estimate alpha hat and beta hat. Why? Because our model says yi equals to alpha plus beta xi plus ui. Unless I know that expectation of ui equals to 0, I cannot say that expectation of yi given xi equals to alpha and beta. And unless I remove that ui, it is difficult to estimate that model. So, that is why this first assumption is required for estimation. Normality of the error term is not required for the estimation purpose. So, that means an econometric analysis, if you think in this way, econometric analysis there are two steps. First one is estimation, and second stage is basically inference making. So, this is required here in this stage, expectation of ui given xi equals to 0, and this requires inference making or hypothesis testing. We discuss in detail later on. This requires ui to follow a normal distribution with 0 mean or sigma square variance or some other normal distribution. I am not very particular about what should be the variance of this, but it should follow a normal distribution with either sigma square variance or unit variance, whatever. So, that is why I am saying this is required for inference making. That is the assumption what we make about the error term. Okay, that is what the assumption we make. Then the fourth assumption, it says, which is again very important, that the values of xi's are fixed over repeated sampling. Now, this assumption is little difficult to understand, and I will explain that with the example once again. We will use the same example here. What I said, these are my x values 60, 80, 100 and 120, and these x values are fixed over repeated sampling. Now, this entire 16 observations, 16 families, they consist of my entire population. From that population, I can always draw a sample of 4 families. And how can I do that? Let us say that this is my y I and this is my xi. For the first case, let us say that I am taking only the first element of each group, that means 40, 60, 80 and 100 randomly I have taken, but x values are 60, 80, 100, 120. This is one sample, sample 1. Now, I can draw another sample taking, let us say, second element of from each group. Randomly I am taking and somehow second element is coming. So, what will that sampling look like? Y1 and xi if you plot, then that will become 40, sorry, this is now becoming 45, 65, 85 and 90. I am taking second element from each group, but my x values are still 60, 80, 100 and 120. What does it mean? It means in repeated sampling, while you can draw a particular family randomly from each group, your x values are fixed 60, 80, 100 and 120. Whatever sample you draw, first of all you must fix your x values, otherwise I cannot fix the group from which I am going to take a particular household randomly. That is why it says that xi's are fixed over repeated sampling from the given population, because yesterday we discussed that from a given population we can randomly draw n number of samples, but of course in reality we are not going to collect n number of samples, rather we will draw only one sample, but we should draw the sample randomly so that I can get a distribution of my estimated parameter beta hat. Unless the sample is drawn randomly, I can get only one such sample non-randomly drawn from the population. Okay, non-randomly drawn from the population. That is why when I am saying that xi's are fixed over repeated sampling, I am saying that since the sample is drawn randomly, I can generate many samples from the given population, but my x values are fixed at 60, 80, 100 and 120. That is what it means when I am saying that my x values are fixed over repeated sampling. Okay, repeated sampling. And assumption number 5, which is actually derived from assumption number 4, when the values of xi's are fixed over repeated sampling, we say that the covariance between xi and ui is 0. That means covariance between xi and ui equals to 0, and that indicates xi is actually non-stochastic. Or xi is exogenously given. So, income level of the individuals are exogenously given, and that determines somebody's consumption, which is actually endogenous in this model. So, these 4 and 5, these two assumptions are very important, but they represent mostly the same thing. When I am saying xi's are fixed over repeated sampling, you can fix the values of x only when that is exogenously given. If the variable is determined from within the system, then that is called an endogenous variable for which you have no control. You cannot fix. That is why I say that xi's are fixed over repeated sampling, and for that reason xi's are called non-stochastic. That is why xi is called exogenous variable, and that means covariance between xi and ui is actually 0. Okay, is 0. but in reality many a times this xi may become endogenous in nature. That means, in reality we may get situations wherein the covariance between xi and ui is actually not equals to 0. And if they are not equals to 0, xi becomes endogenous, we need to apply a different estimation technique, different from what we are going to learn in CLRM, to ensure that our estimates alpha hat and beta hat, they exhibit the 3 desirable properties: unbiasedness, efficiency and consistency. That is why I said these are the assumptions what we are making to describe the idealistic world, but reality might be completely different. And if the reality is different, then obviously we cannot reach towards God. So, we must ensure if there is any problem, we must rectify. In the data, if these assumptions are not satisfied, then we need to rectify those. That is why first of all we should know what is that idealistic situation, what are those assumptions that we make, so that our estimates, they exhibit the desirable properties. There are another 4 to 5 important assumptions describing this idealistic world before we estimate the model using CLRM. Those 4-5 assumptions we will discuss in our next class. Thank you very much.